Are there any questions over any of the homework assignments? Any questions over any of the homework assignments? Yes. Would this be false? If it is daytime, then the sun is out.
So I'm thinking about like places like Alaska where it can just be dark for like.
Let me see here, 22. And that's for 2.1, yes? Yes. If it is daytime, then the sun is out is false. And you had the other one correct as true. Guys, the first one would be true for that one. Any other questions on the assignments? Okay, guys, so let's go on and start the note sheet for today. Now, I gave you two different ones. Yep. So one of them is the note sheet, and the other is a postulates sheet, a reference sheet. So the postulate sheet and reference sheet is going to be a resource tool that you can have, and you will be able to use it along with the review sheet on the test. Because I'm not expecting you to memorize all the postulates we will look at, especially the ones we'll look at today. So you can utilize that worksheet or that sheet to look back on it to see it. So we have 6 for sure. Now when we look at this first one here on the note sheet, the 2-point postulate. The 2-point postulate states that through any 2 points, there exists exactly one line. So if I have one line, or if I have 2 points, I can draw a line through them. That's what the 2-point postulate says. So given through points A and B, there's exactly one line L. Now the line point postulate states almost kind of going the other way around. If there is a line, if a line exists, then it contains at least 2 points. A line contains at least 2 points. That's the line point postulate. So if I have line L, then there exists at least 2 points on it. That's it. The line intersection postulate states if 2 lines intersect, then their intersection is exactly 1 point. So given lines N and M, they intersect at point C. The next postulate that we do have is the 3-point postulate. Through any 3 non-collinear points, there exists exactly 1 plane. So if I have 3 points, 2 of them could be on a line and 1 of them can't, or all 3 are not on a line, we can make a plane. We can name a plane. That is the 3-point postulate. Through any 3 non-collinear points, there exists exactly 1 plane. Through points D, E, and F, there is exactly 1 plane R. Now the plane point postulate, just like the 2-point postulate and line point postulate, they kind of work about the same. The plane point postulate states that a plane contains at least 3 points. So plane R contains 3 points. That's it. That's all there is to it. The plane line postulate states if 2 points lie in a plane, then the line containing those points is in the plane. So we can use 2 points on the plane to make a line, and that line will also be contained in the plane. And last but not least, the plane intersection postulate states that if 2 planes intersect, their intersection is a line. And that's it. Questions on any of this so far? Okay. What we want to do with this here is we want to name the postulate described in the diagram. If this here, then we have this here, and draw that in a little better. So if, well, what is this first picture showing us? If two lines cross, yes? Then the point. So if two lines cross or intersect, then what? Is a point, yes? What postulate is this talking about? Mm-hmm. And that's it. Now, this reference sheet is in your textbook. It is on page, I think it's A110, because it does, I think one of the pages says it at the bottom. A101 is where the postulate section starts in the textbook. So these are just pulled straight from the textbook. And I'm not expecting you to memorize these. There's too many of them. Questions on this here? Let's look at the next one. If this picture, then this picture. So what's our first picture showing us? What is that? Two planes that are. And then it highlights this here. Then they intersect at A. So what's the postulate? Plane intersection postulate. Plane intersection postulate. Because if two planes intersect, their intersection is a line. If two planes intersect, their intersection is a line. Questions on this here? We good with this here? Okay. Let's look at another one. If this picture, then this one. So if, well, what do we have here? A line, then we have 2 points on the line, yes? Is this the 2-point postulate, or is this the line point postulate? What did we start with? So that's the 2-point, yes? So what did the 2-point postulate start with? Through any 2 points, there exists exactly one. Well, what did this start with? A line, yes? What's the line postulate say? So the line point postulate says a line, so we're starting off with a line, contains at least 2 points. So this one here is starting off with a. So this is the line point postulate. It would be the 2-point postulate if we started out with if points A and B. If there were 2 points, then we had a line through those 2 points. Then it would be the 2-point postulate. Because 2-point postulate starts with 2 points, then we can draw a line. Here it says if we have a line, then there are at least 2 points. This would be the line point postulate. Questions on this here? If we have what? If we have 3 points, then a plane, yes, because we started out with 3 points. 3-point. This is the 3-point postulate, because the 3-point postulate starts out with 3 points. If there are 3 points, then we can construct a plane. It would be the plane point postulate if we started out with a plane and then we're given 3 points. Questions on this here? Now the next few, and quite a few that we'll do, is naming examples of these. So they're going to give us the postulate. So use the diagram to write an example of the plane point postulate. So we're going to start out with the plane point postulate and then do the plane line postulate. Well, the plane point postulate stated what? If we have a plane, then there is at least 3 points contained in the plane. So, which plane has at least 3 points in it? Plane P. Plane P contains points, what? B, A, and C. Because the plane point postulate says if given a plane, we are given plane P, it contains points B, A, and C. Mm-hmm. That's it. That's all we have to do for this here. Yes, sir. In a little bit. Any questions on this here? Okay, I'm going to erase this here. Points A and B are also in plane P. Now, the next one we want to look at is the plane line postulate. Well, the plane line postulate states if 2 points lie in a plane, then the line containing those 2 points is also in the plane. So which plane contains 2 points in a line through them? Well, line M is in both, yes? Are there 2 points that go through line M that are labeled here? No. A and B would be, yes? So we're talking about, so plane B, plane P, contains points A and B and the line AB. Or in the line through it, or something along those lines.
That was good. It's lines.
It's lines.
Really big of a shirt. It looks like the Nashville Predators.
I think my sister or someone got it for me because of that.
Really?
Any other questions on example 2, this example here? Which postulate which postulate allows you to say that the intersection of plane P and plane Q is a line? Which postulate allows you to say that the intersection of plane P and plane Q is a line? Plane what? Intersection postulate, because the plane intersection postulate states what?
If 2 planes intersect, then their intersection is a line.
If 2 planes intersect, their intersection is a line. If 2 planes intersect, their intersection is a line. Questions on this here? All right. Let's look at an example of each one of these here. Two-point postulate. Well, the two-point postulate states through any 2 points there exists exactly one line. So when we look at this here, we can say through points A and B, there exists line AB. Now we don't have to specifically write out line AB because AB with the line above it is the line AB. And that's it. That's all we have to say for this.
Look, that's all we're doing today?
I mean, well, we have a few more, but that is part of the homework. We'll be doing that. List an example of 2 points. List an example of this. Questions on this here? Okay. Line point postulate.
Hey, next time you write something down, I'll show you.
Okay. Tap in the middle. So line point would be what? Line N contains points A and B. Line N contains points A and B because the line point postulate states, given a line, it has at least 2 points. A line, given a line, it contains at least 2 points. So line point postulate, our example is line N contains points A and B. That's it. Questions on this here? And the last one, the line intersection postulate. Well, the line intersection postulate stated if 2 lines intersect, their intersection is a point. So line M and line N intersect at point what? A. Line intersection postulates would say that line M and line N intersect at point A. And that is it. Questions on this here? Okay. Yes. Mm-hmm. Yes. Quotient would be dividing. We good with this here? The next few will be sketching a diagram. Sketch a diagram showing that line TV intersects PQ at point W, so that TV and WV are congruent. Well, TV is what? A line. So I can make a line and have T and V. And then the other one is a line segment because it does not have the arrows on either end. And we can call it PQ. And their intersection is point what? Is there anything else we need to add? So we have a diagram showing TV and line TV intersecting line segment PQ, yes? Okay, we have that. And it's at point W. So that what? TW is congruent to VW, yes? Right, so how did I symbolize something being congruent? Or line segments being congruent? There was a symbol. is those little hash marks signal that they are congruent. As we saw them when we talked about congruent segments in chapter 1, where we had the little marks on them for midpoint. So it would show that these two are congruent. Now, I know this is not in your note sheet. Don't worry about trying to write that down. If the given information states that PW and QW are congruent also, how can we indicate that in the diagram? Well, I can put two of them. Because if they were all congruent, if T, W, V, W, PW, and QW were all the same, we would put how many on each one? Just one. Yes, sir. Yes. If I put a second one down, it means the ones that have two are congruent to each other, and they are different from the ones that contain one, because all the ones that contain one would be congruent to each other. All the ones that would contain two would be congruent to each other. And if we had three, those would be congruent to each other. And that's it. Questions on this here? Okay. Okay, let's look at this here. Sketch a diagram showing that ray Vx intersects line UV at point V, so that Vx is perpendicular to UV, or UW, and UV and W are all collinear. Wait a minute. If these are collinear, it means they're what? On the same line. So really we have a line with what? U, V, and W. Because we know V is going to be between U and V, most likely. So we do have this part down. We have that they're collinear. Bless you. Now, Vx and UW, ray Vx and line UW do intersect at what? Perpendicular. Two lines are perpendicular if they make what? Right angles. Okay, so perpendicular means they make a right angle. So what we can do, we can draw a line going straight up, perpendicular, and to signify that it is perpendicular, we will do one of the little right arrow, or the 90-degree markers here to show that it is perpendicular. And our letter up here would be X. Have a good one. So looking at this here, we do have a ray and a line intersecting, yes? Because they intersect at point V. We have that. We also have shown that this ray is perpendicular to the line. It makes a right angle to it, so that works. And U, V, and W are collinear, yes? That's it. That is it. That's all we have to do for this here. Yes? No? Okay. Now we do have a few more, and the last few are not as bad. We're not actually going to have to write more than a word for most of them. A line is perpendicular to a plane if, and only if, the line intersects the plane in a point and is perpendicular to every line in the plane that intersects it at that point. So it's going to be perpendicular to every line that I could create on the plane through that point. In the diagram, a line is perpendicular to a plane must be marked with a right angle symbol as shown. We could use two, or we can use at least one. It needs at least one to show that it is a right angle. So let's look at this here. So when we look at this here, points, which of the following statements can be assumed from the diagram? So the first one, points A, B, and F are collinear. Are they on the same line? A, B, and F. Yes. Are they collinear? Well, yes, because we see that there is a line and all three are on the line, yes? So can we assume that? Yes. Can we assume that points E, B, and D are collinear? E's all by himself over there, so no. Can we say that AB, line AB is, what, does anybody know what the symbol is? Anybody have a guess?
Line.
Perpendicular. That is the symbol for perpendicular. Can we say that line AB is perpendicular to plane S? Because they gave us that little box right next to the line, so yes, it means that it's intersecting the plane at a right angle. Because if it intersects the plane at a right angle, then it is perpendicular to the plane. Any questions on the first three? Let's look at question number 4. Is line CT, CD, perpendicular to plane T? Do we know anything about their intersection there? No. Could they be intersecting at a right angle? Maybe. Probably not. It doesn't look like it. But unless we're specifically told that it is a right angle, then we don't know. Because if it tells us it is a right angle, then yes, we can. But it being a right angle has to be told to us. We can't just look at it and tell.
Guess.
Intersection of line AF and BC is point B. Is that true? Can we assume that? Well, yes. Because if we look at the diagram, AB and AF do cross through point B. So yes. Any questions on these here? Number 5. Can you assume that plane S and plane T intersect at line BC? Yes? Because that is where they intersect. That's where the two planes cross. Because we can see that that's where they're crossing at. So yes. Explain how you would know that line A, B, and BC are perpendicular. Yes, sir. Yes. A 90-degree symbol at their intersection. So where the two lines cross, there is a 90-degree symbol, a right angle symbol. So the two must be perpendicular. Any questions on this here before we cover the next piece of information? Yes. We good? And that's it.